Okay, we will start. I hope the screen is visible. Is the screen visible to all? Please let me know. Let me check whether I have started the. Yes, mic is on. Okay. Right. So now we have discussed till now the different types of steel structures. We have also seen how they are made. We have also gone through different shapes. Then slowly we have studied the classification of cross section with respect to beam. So there are four major classification of cross sections, that is plastic, compact, semi-compact and slender. And this classification, it completely depends on the behavior of that particular cross section which we are studying. So it is not the shape, it is connected with the behavior of different shapes. Okay. Then we also saw different types of connections which are available, isn't it? So depending upon the types of connections, as we have discussed, the bolted connection as well as the welded connection and riveted connection, there is one more term which is known as moment resisting connections. So in order to understand moment resisting connections, we should first of all know what are different types of bolts, how the bolted connection is done, and similarly what are the different types of welds and how that welded connection is to be conducted. So firstly we will target about bolted connections. So we saw such different types of connections, and these connections are again classified, and classification is again based on the behavior of that connection. So depending on different behavior, as you can see, these are the concentric connections. We assume that all the forces are passing through same point as shown in this figure. So this is all theoretical. There may be small amount of eccentricity because of which there is moment which may be generated. So, but that eccentricity is so very small that it can be neglected, and therefore we can see all the forces can be considered to be passing through single point. Similarly, there are moment types, moment connections. Then the classification which is based on different types of joints. So you can see this is lap connection. Okay, this typical connection is known as lap connection, and this joint is known as lap joint. Similarly, this connection is known as butt connection, and this joint is known as butt connection or butt joint rather. And we have also discussed about this condition or connection wherein tension is applied and the bolts by which the connection is done, they are subjected to tension force. And similarly, this is the most common whenever we provide bracings or diagonal members. In those members, we will expect such kind of tension plus shear type of connections. Okay, so this is very frequent. Then we have also seen what are the different types of force transfer mechanisms. First force transfer mechanism is bearing, and I think I had told you that when this bolt which is inserted in the hole which is created in the plate, when it comes in contact with the plate surface, some force is exerted by the plate on the bolt, because of which stresses are developed. Those are known as bearing stresses. Okay? Mostly the plates they fail in bearing because the grade of the plate is most of the times it is weak compared to the grade of the bolt. Now, last time I had told you that we will see few uh, videos wherein you will understand what are the different types of failure associated to a bolt connection. So, second type of failure is bolt in shear or failure in shear. Okay, so let us try to see. See, there are two parts. One, either the failure may be associated to the bolt or this failure may be associated to the plate. So let us see how the plate fails in shear, and similarly we will see how the bolts may fail and what must be the reason why the shear failure of the plate may take place. The reason is only, it is very simple. If the grade of the steel plate is less compared to the grade of the bolt, in that case you will find the failure of plate will take place. That may be bearing or that may be shearing also. Let us try to assess what is the uh, how it how the shear failure can occur, that we will see. Just wait for a while. So anyway, the video will open for now. See, if we consider such kind of connection, what kind of connection do you observe over here? We have studied the different types of connections, or classification of connection. So, what this connection may be? Can anyone tell me? Yes. What is the type of this connection or joint? Lap joint. Lap joint. Correct. So this is a lap joint. Over here, now if I consider the bearing stresses, those may come into picture for this kind of lap joint. Here, what do you observe? There are two plates, isn't it? There are two plates which are getting connected with the help of this bolt, right? And now, if I apply force in this manner, what do you observe? That this portion of the bolt will get in contact with the plate surface. After some time, after with the increase in this p value, you will find that this surface will be in contact with the plate surface. Surface of the bolt will come in contact with the plate surface, and because of which the stresses are developed. These are known as bearing, and these stresses are developed from the plate, as you can see over here. Similarly, on this face, you will expect that this face of the bolt will come in contact with this face of the plate, since we are pulling this plate in this direction. Similarly, over here also you will anticipate bearing from the plate. And a typical shear force diagram, if you want to plot, that will be in this manner. Okay, so the increment of the shear force will be from this to the maximum value, and then from this to the maximum value. So this is the maximum bolt shear which we can plot, and this is true for uh, two plates which are getting connected with the help of one bolt. If I consider this is again a lap joint, thick, but in this case we will observe that there are three plates which are getting connected. And if I apply uh, a pull over here, and if I say that these two plates are connected at other end, so it is but natural for maintaining the equilibrium, p by 2 values will be developed at these two locations. Because of this, what will happen? The bearing stresses developed will be in this manner. So you can see on this face, these bearing stresses are formed, whereas over here and over here. These are the bearing stresses from the plate. And if we draw the shear force diagram associated to this, so what do you observe? There are two peaks, two shear failure, or in short, we call them as shear failure planes. Okay. So when there are three plates, there are two shear failure planes as shown over here. Similarly, if we have two plates, how many shear failure plane do we have? One. Only one. Okay? So there is a formula you can consider if you want to identify the shear failure planes for a bolt which is connected to number of plates. So the formula goes like this. Shear failure plane, which you can call it as S, is equal to n minus 1. N stands for number of plates. Okay, so it is valid. And in this case, how many plates are there? 2. Okay, n minus 1, which will be 2 minus 1. So my S value comes out to be 1, and similarly over here. So this is a generalized equation you can consider in order to calculate the shear planes. This shear plane concept will be useful when we will be solving the numerical. So I hope you have understood the shear plane concept. Okay, let me check whether the video is on. अभी भी नहीं खुला है क्या? Great. This browser is hopeless. 1 minute. One minute. Huh? Bolted connection plate. Yes, this is shear. Okay, this is a very quick video. Now you can see. 1 minute. Huh? Okay, what do you observe over here? That this plate, the upper plate is connected to some connection. It is fixed, and this plate is getting pulled. So you can see uh, the grade of the plate over here. It is less compared to the grade of this bolt. Now you see the behavior, how it fails. Right. This has failed. And if we observe such kind of failure, wherein one part of the plate is separated, okay, you will call this failure to be shear failure of the plate. Okay, so this is how the shear failure is for the plate connection, and this may take place in your uh, bolt as well. So here it is. Here is the explanation or the experimentation. You can see over here. Pull is applied. Yes. So the reason for the shear failure of this bolt was the grade of the plate was more compared to the grade of this bolt, and because of which the bolt it got failed in shear, and it got divided into two parts, as you can see over here in this video. ठीक है? Right. So this is how the failure which is associated to bolt as well as plate with respect to shear that can be obtained. Now similarly over here, there is one more type of failure which is associated to the tension force. Okay, and you can see from this figure, if 2t is the value, just for the simplification purpose, we can consider this value to be 2t. So t and t equal but opposite. These forces will be developed in the bolt. And over here, this is a typical stress which is associated to the tension force, which we call it as to be the tensile stress. These will be developed in bolt. And in order to understand the behavior, you can see. This is actually the plate tearing effect, wherein you will see the typical tearing which took place at this location. Okay, at very early stage itself. It did not go at this level. It has failed at the early bolt hole value, you can say, right? This is different thing. Uh, yeah, okay. So this is how you can uh, understand the various failures which are associated to the uh, bolt failure as well as the plate failure. Okay? Yes. Then the high strength friction grip bolt, the concept which I had told you, these are the most uh, you can consider it to be uh, load. It will carry maximum load, and it will not fail with the help of bearing forces or shearing phenomena as quickly as other bolts they do. Over here, if you can understand, the resistance which is offered by the these types of bolt is because of the frictional force. Okay, and when this frictional force will get surpassed, after that the plate will then come in contact with the bolt, and once it will get in contact with the bolt, bearing stresses will develop. If these stresses are crossed, or if the bearing limit is crossed, then it will enter into the shearing failure zone. So it's a very gradual process. It takes time for the bolt to enter into the bearing stress phenomena. Okay, so these are the high strength friction grip bolt connections which are designed such that under service load the force does not exceed the frictional resistance, so that the relative slip is avoided during the service. When the external force exceeds the frictional resistance, the plates they slip until the bolts come into contact with the plate and start bearing against the hole. That is nothing but the bearing action. Beyond this point, the external force is resisted by the combined action of the frictional resistance and the bearing resistance. So these are the different types of bolts which are subjected to different failure conditions. So all these things we should know prior to uh, solve any numerical or consider the connections. Okay? So I hope this is understood. Okay. Now let us browse our IS 800 2007, and let me cover all those points which I did not discuss in the theory class. So these nomenclatures and all, everything I think I had told you. Now, yes. Uh, Now, this part, this is the general introduction that already we have covered. Okay, rivets, related to rivets. Yes. So before discussing that, let us see this table. This table is very important for us. Okay, table number one. We shall be referring every now and then. And while solving numerical, we will take care that we will give the reference of all the clauses, relevant clauses. This will help you people making a report. See, whenever you join any company, uh, in that company you are, I mean, there are few expectations from any engineer that first of all that engineer should be able to design certain components, and once that component is designed, uh, then the next process is your construction phase. But before that, whenever you are designing any component, you are supposed to provide the client or whosoever it may be, that person, you are supposed to provide with a report, and that report should consist of all the necessary information which will convince that client or that person that yes, your design is up to the mark, it will be safe. And why it will be safe? Because you have referred certain standards. Okay, so whenever you are using any kind of equation, whenever you are using any material property, you should be in a position to tell that from where that component or what from where you have considered that value. That is very important. And we will make a practice. Whenever we solve any numerical, we should write the references. For example, if I am solving some numerical related to bolted connection, and if I want to say that I am making use of grade 4.6 bolt. So for that, I need to know what is the ultimate capacity, ultimate strength, tensile strength of that bolt, and from where will I get that value? From here, from this table. Okay, so just for the example, see over here, as you can see, this is 4.6 grade bolt, right? And the ultimate tensile stress or strength value, you can find it over here. It is 400. So no one can cross you. No one will ask you that why you have considered 400 value. If provided if you give the reason that I have used this value from table number 1, page number 13 of IS 800 2007. Okay, so from that, no one will dare to ask you that from where this value has come, or if anyone wants to cross verify, that person may do that. So this is what a report is all about. This is one small example which I have given. There are so many other parameters which a report will consist of, right? But to begin with, we should be in a position to refer all these components. Am I clear? Is this okay? Yes?
Yes.
Okay, fine. So now you can see this table is essential. One hint I have given that we will be using this whenever we come across a bolted connection. So there are different grades of bolt which are given over here, and the necessary information is also given over here. We will be referring this table. Next, this table 1 is again continued on page number 14, and over here you will see this. I have already discussed about this uh, part. That is IS 2062. This is for the plates, right? So we will understand what is the significance of this, why we are using this and all. Okay. Yes, now see. Yeah, riveted connection. Rivet shall confirm so and so this thing. And this is the clause related to bolts, nuts, washers, etc. Right now we are discussing everything with in relation to the bolts. And initially we will discuss about the beam part or the horizontal member. Then slowly we will shift to the diagonal members or the members which will carry axial forces. Okay, we will try to understand them first, and then we will go to the vertical component of the structure, that is your column. Okay, again I am repeating, classification of cross section, whatever we have seen, that was related to the beam part. Column ke liye that is different, although the classification, four classification may be same, but the description is bit different. Okay, so yes, right. देखो एक statement लिखा हुआ है in methods of design. Okay, so be careful over here. Structure and its elements shall normally be designed with limit state method. क्या बोल रहा है? Shall normally be designed by limit state method. Account should be taken of accepted theories, experimental information, and experience, and the need to design for durability. Calculations alone may not produce safe, serviceable, and durable structures. Suitable materials, quality control, adequate detailing, and good supervision are equally important. See why this statement is made, because you can see there are number of mishaps which are happening. Sudden failure of bridges, flyovers, or any structure, although they are constructed uh, recently, isn't it? They fail. But you cannot blame any structural designer directly. You have to first of all see what was the cause of the failure, and that failure may be because of this. Okay, uh, calculation may not be only cause. Suitable material, quality control, adequate detailing, and good supervision. This is very very important. Okay, this may also cause the failure. See, even though in the design we take care of the factor of safeties and all, ये लेने के बावजूद अगर सुपरविजन ही ठीक नहीं रहा तो it is worst. Okay, then one statement, where the limit state methods cannot be conveniently adopted, the working stress design may be used. This statement is written. Okay, this statement you can correlate with the design of spatial structures like uh, water tank design, sometimes bridge, because nowadays bridge design is done with the help of limit state method, but most of the designers they find it convenient to design the bridges with the help of WSM also. Okay, so water tank, then some special structures like chimneys. Okay, over here you will find that working stress method design is best, because over here workings in working stress method design you do not accept any kind of crack to be developed. We do not permit that. Limit state design, yes, crack of some width is acceptable, but in water tank there should not be any scope of any kind of crack. Okay, so one statement we can correlate this statement. Okay, next, these are the loads and forces which I have discussed. Dead load should be assumed in design as specified in IS 875 part 1. I hope that you people have downloaded this IS 875 part 1. In addition to this, you are also supposed to download part 2, which speaks about the imposed loads. Then snow load is not that much important. That is described in part 4. Wind loads, this is very very important and you should download this. Okay? And earthquake loads, these are special loading conditions which you can find in IS 1893. There are two versions. One is 2002 and another one is 2016. So latest is 2016. Then the erection loads, temperature effects, all these things I have discussed in brief. So this I will browse. Yeah, now this is important. Dekho, classification of cross sections. Okay, and again I am repeating, this is for beam. Okay, एक paragraph पढ़ता हूँ and we will try to assess whatever we have learnt, whether it is in line with this or not. क्या कहता है? Plate elements of a cross section may buckle locally due to compressive stresses. I will read one more time. Plate elements of a cross section. Now you can consider an I section. Let's discuss about I section. I section, if you see the cross section of this I, you will understand that the upper flange, the lower flange, and the web, you can consider these to be three different elements. Do you remember I had told you that the members or the components of any cross section will now be called as elements. Okay? These elements, you can consider them to be separate. Upper flange to be a separate element, web and lower flange, these three to be separate elements. So these plate elements, they may buckle locally due to compressive stresses. So do you remember one video which I had shown you wherein the beam was subjected to vertical force? That cross section was again I cross section. In that, the upper flange, there were undulations, and these undulations were perpendicular to the direction of the force which was applied. This is known as local buckling. Okay, so the local buckling can be avoided before the limit state is achieved by limiting the width to the thickness ratio of each element. The aspect ratio which I had told you, width to the thickness, that means the larger dimension to the smaller dimension. If this ratio is maintained properly, then we are in a position to avoid this local buckling phenomenon. Okay, how to avoid, what will be the aspect ratio, what should we consider, everything is given for your reference. Slowly we will enter into that. तो देखो क्या कह रहा है वो, local buckling can be avoided before the limit state is achieved by limiting the width to thickness ratio of each element of a cross section subjected to compression due to axial force, moment or shear. So it is not necessary. One video which we saw was the one which was subjected to vertical force, but you may experience compression which may be developed because of some axial force, right? It may also be because of the moment and shear. Okay. When plastic analysis is used, the members shall be capable of forming plastic hinges with sufficient rotation capacity, which we call it as the ductility, without local buckling to enable the redistribution of bending moment required before formation of the failure of mechanism. So if you remember, we have drawn that idealized stress strain curve, that too bilinear, isn't it? In that we have we said that the material will yield up to the plastic hinge, up to the plastic hinge formation. Such type of material, you can consider it to be the ideal material. or such type of cross section you can consider it to be ideal cross section. Why ideal? Because this cross section has developed plastic hinges. And what was the reason of creation of plastic hinges? The various elements of these cross sections, they did not fail locally, or local buckling was not observed, because of which the complete cross section was able to develop that plastic hinge. Okay, so this is what is the concept of the plastic theory or plastic analysis, which we have seen in brief. Next, when elastic analysis is used, the member shall be capable of developing the yield stress under compression without buckling. That means the semi-compact stage. Okay, semi-compact stage में क्या होता है? Yield हो जाता है material, but it is not in position to go beyond that yielding. That is, it cannot enter into the plastic zone. Why? Because some of its elements or some of the components of the cross section, it is failing because of local buckling phenomena, right? So that stage is your semi-compact stage. Okay? Then description related to plastic, compact, and semi-compact and slender. This is given. So the thing which I have been repeating, that is given in paragraph. जैसे cross sections which can develop plastic hinges and have rotation capacity required for failure of structure by the formation of plastic mechanism, the width to thickness ratio of plate elements shall be less than specified under class 1 in table 2. Okay, so the question must have arisen in your mind that what should be the width to thickness ratio, or what should be the aspect ratio for different types of cross sections. So IS 800 2007 has provided one table number 2 which speaks about this aspect ratio, and it says that this should be the limit beyond which the classification cannot be justified. For example, these are the compression elements, various different types of cross sections you can consider, wherein you will find, for example, this web of a channel. Can you see this web of a channel? Channel section is nothing but your C section. So as per your IS code, what it says for defining the class 1 or plastic classification, for a web of channel, the value of the width to thickness ratio, it should not be more than 42 times epsilon. Epsilon का मतलब क्या है? ये epsilon is nothing but under root of 250 divided by Fy. Fy is nothing but the yield stress, and most of the time yield stress value is 250. So this value of epsilon, most of the times it is 1. Okay, fine. So we will come across various cross sections, I mean shapes. For example, angle, then single angle, double angle cross section. We will see how these double angle sections are. Okay, so for all the different types of conditions, the width to thickness ratio as per your IS code, they are defined for different types of cross sections. Okay, so this semi-compact section is nothing but your you can correlate this semi-compact section to your working stress design. Okay, these are just the glimpses. Okay, we will be using all these tables, all the references whenever we speak about, we will be solving about various numericals. Okay, yes. Now देखो, these are different cross sections, and the various terminologies are based on which we will be in a position to find out different unknown parameters. Like for example, the width to thickness. For example, over here, if I'm talking about the web portion, and if I want to find out the aspect ratio in order to define some classification of cross section, in that case, this D and this TW, these two values will be important for us. तो अभी ये देखो आपको ये जो D है ये कहाँ से शुरू हो रहा है? From this point to this point. And if you observe very carefully, the I section at this location, it is curve. It is not a straight connection as can be found over here. Okay? It is a curve. It is not straight line. So again, there are few conditions which are to be adopted, and based on those conditions, this D value is to be evaluated. So we will see to it how to calculate this D and all. Okay, so this will be the D by TW ratio for the web. Similarly, for the flange, this will become the B by TF ratio. That is your aspect ratio. From here, you are supposed to refer these values. D, B, TF, TW. Okay, TF is nothing but thickness of the flange. Are you getting me? ठीक है. Then this is related to the slenderness ratio, which is very important for our vertical members. Okay, that we will discuss later on. Most important things which I wanted to tell you. Yes. Right. So this section, it is methods of structural analysis. So various glimpses related to the structural analysis methods, they are provided over here, and we can make use of all these parts in order to first of all analyze the given problem, and later on you can go for the designing part. Okay, designing is also given, how to design, what should be the formulations that should be followed in order to design various components, that is also mentioned. So this section, it covers analysis part. So over here elastic analysis is also given, plastic analysis is also given, and this plastic analysis, few formulations, that those we will be referring in our limit state design method. Okay. Yes, so this is the limit state design section 5. Over here, I request you all to please go through this section very thoroughly. Please go through this, right? And try to understand what is given over here. And you also refer the content of the books, journals, whatever you feel like to. Try to collect as much information as possible, and you write down the practical number 2 which I have given. I think I have given this question wherein you are supposed to write about the limit state design method. So you are supposed to prepare the notes accordingly. Take the help of this IS code, take the help of book or other references, standard references obviously, and try to understand and develop your own notes. Okay? So this is very important. Limit state of design. What exactly it is? For achieving the design objectives, design shall be based on characteristic values for material strengths and applied loads action, which take into account the probability of variations in material strengths and in loads to be supported. So just remember, I had told you about the partial safety factor concept, isn't it? In that, you must have understood why exactly we are applying these factor of safeties. What is the purpose? And in limit state design, you will observe that these these factor of safeties, they are applied to the material and the load. Purpose. What is the purpose? Can anyone tell what was the purpose which we have discussed? Yes. Please let me know. Do you remember what was the purpose? Why? Hmm? Anyone? Just we will discuss. Why it is known as partial safety factor? Okay. So see, what is the reason why do we call it as partial factor of safety? Because there are uncertainties as far as load is concerned and as far as the behavior of the material is concerned. Because material, different materials, they behave differently. Although, I mean, even if we consider steel and if we prepare eye cross section for steel, no two cross sections, although it is of same length, same dimensions. Okay, when we are doing hot rolling process, in that you will find that these two elements, although they are of same cross section, same dimension, same size, the behavior may be different because during hot rolling process, as we have already discussed, that there is a residual stress which is developed because of sudden temperature variation, because it is allowed to cool suddenly after the cross section is developed. That cross section is allowed to cool suddenly, and because of which some stresses, residual stresses are there. And by the virtue of these stresses, the various parameters like the modulus of elasticity, Poisson's ratio, etc., thermal coefficient of thermal expansion, all these values, they may vary, and you will find that there is variation in two samples. Okay, so in order to cater these uncertainties, we provide what we call it as the factor of safety, so that it will not fail after it has been constructed. Also, we also take into account the poor workmanship factor of safety or some accidents during the construction on the site. So, based on this, this is. But in order to identify these partial factor of safeties, this probabilistic approach is conducted, wherein the characteristic value is identified. Are you aware of this characteristic strength? You must have used this characteristic strength value in your RCC. Do you remember this thing? So, what was the idea? What was the idea in identifying the characteristic strength of, let's say, concrete, for example? Yes, and while identifying that, uh, do we see that all the samples which you have prepared, they will exhibit the same nature of characteristic strength value? It is different, and in order to optimize that, what do? We take number of samples, minimum 30, minimum 30 samples are to be taken, and from that we plot a curve, bell shaped curve, isn't it? And that bell shaped curve, from that we make use of the standard deviation and mean concept. From that we identify the characteristic strength value, isn't it? Similar type of approach is followed in order to calculate the characteristic values for load as well as for your strength of the material. These characteristic values are nothing but your partial safety factors. So now just try to understand how much difficult it is to identify the partial safety factor values as far as limit state design is concerned. We are supposed to take a number of samples, plot the curve, identify the characteristic value, and then propose that particular value for different situations. So if you remember, I will just browse that table wherein you will find the partial safety factor values are given. So it is over here. This is very important. Table number 4. तो ये देखो यहाँ पे 1.5, 1.2, 1.2, 1.5. One combination has to be considered for 0.9. It is reduced. Okay? Most of the time you will find that these partial safety factor values for dead load and live load, they are increased. For one condition only, it is decreased. That is 0.9. Because this is a horizontal force which is applied, and it is considered that the combination based on this dead load and plus minus wind load or earthquake load, if this combination persists, since this is horizontal loading, the vertical loading may not be that much critical, because you will you see this, because of this combination there is a overturning effect, isn't it? Overturning may occur, and in order to incorporate that overturning effect, this dead load value is reduced. That reduction is done. This value is actually taken from the British standard Eurocode. Okay? And in Eurocode you will find this value is adopted. They have considered it to be less than 1. Other codes, they have also considered less than 1 value, but their approach is different and their values are also different. That value ranges from 0.8 to 0.9. So it may be between that also. 0.85 bhi hai koi code mein. I think in the Australian code or so. So we have adopted 0.9 value, which is less than 1. This gives critical combination and critical value for this loading. Okay. So you can see all these values which are provided by the IS code. They are based on the characteristic value concept. It has been identified based on such a research. Okay? This is not only for the loading but also for material, which is given on page number 30, table number 5. Got it? Okay? So characteristic action loads, तो ये जो है इसका explanation है. Okay, and you can see how these characteristic values are used in order to calculate the design values, that is design load and design strength. Here the formulation is given. So you can see gamma fk, it is partial safety factor for different loads and number of loads k given in table 4 to account for why is the necessity of this possibility of unfavorable deviation of the load from the characteristic value. This is the characteristic value. Possibility of inaccurate assessment of the load. Uncertainty in assessment of effects of load. Uncertainty in assessment of limit states being considered. There may be a possibility that we may consider some other value for the limit state of strength or serviceability. So in order to incorporate all these things, we need to consider the partial safety factor. So a great amount of thought process is involved in order to define all these things. Similarly, for strength, what is the requirement? Loss of equilibrium of the structure or any part of it considered as a rigid body, and failure by excessive deformation, rupture, or loss of stability of the structure or any part of it, including support and foundation. This is the design strength value which we shall be using, and for that you can see this is the ultimate strength and this is the partial safety factor. Why? To account for the possibility of unfavorable deviation of material of the strength from the characteristic value, unfavorable variation of member sizes. See, because what we are doing, we are making use of the hot roll section, and hot roll sections, they are not up to the mark. The diamond, the cross sections are deviation. You will find there are various deviations. Okay, it is not smooth as your cold form sections. Possibility of unfavorable reduction in the member strength due to fabrication and some tolerances. Uncertainty in calculation of strength of the members. So this will take care of, it is said that it will take care of all these possibilities. But even though there are chances of failure, and those chances are only because of wrong supervision. Okay? So that supervision part, it also comes into picture. Right? So these are different factors which are governing the ultimate strength. Okay? Then this is the deflection part. Okay, these are the deflection limits which are proposed. This is nothing but the limit state of serviceability. So from here, you can check whether whatever design you have proposed, whether it is safe for serviceability limits or not. So these are different conditions and these are different limits which are specified. Okay, all the types of buildings are covered, industrial and other buildings. Yes, and then we shall be discussing about the tension members. Okay, and we will see what are the different formulations associated to this and how these tension members are to be designed. So slowly we will be entering into the numerical aspect, but before that we should know what are the essential values and essential clauses. Those will be helpful for us to identify the or to design several components or elements. So I hope this is okay with you people. You are supposed to read this IS 800 2007 thoroughly. In case you find any kind of difficulty, we will discuss. Okay? So I will stop here, and the second this second practical I will upload the date. Okay? And accordingly you are supposed to submit the same. फर्स्ट प्रैक्टिकल आज की डेट है, आप सबमिट करो. Okay, again I am repeating that this practical number 1 is of dynamic, it is of dynamic nature, and you are supposed to submit whatever you have seen till date today only. Later on you can keep on modifying that practical. Okay, I will come to know the date on which you have modified it, but make sure that you do not modify the document which you have uploaded today. You can add another document. You can give the reference where you are supposed to do the correction. Okay, and I will come to know where you have modified. Is this okay? Okay? Okay, fine. So I will stop here. You people can leave. Thank you.